Okay, let's go ahead and start by looking at today's do now. Here we're looking at Maria had owed her grandfather, so we're starting in a situation where we are at negative 2.25, but was recently able to pay him back. Okay, so we're positively increasing our value by paying him back. What is his current net value with her grandfather? So we're looking for the answer here. Quickly thinking about this as a quick sketch on the number line. We're back at negative 2.25 and then forward 1.5. That's not going to be enough to get us to positive, so we are going to have signs cutting across from each other. 2.25 minus 1.50. And do the math. It's going to give me 0.75. And again, we can look at our arrow diagram really quickly to identify that this is going to be negative because we are more negative than we are positive. So that's going to give us a negative 0.75. And the real world context behind us would tell us that we still owe our grandfather 75 cents. All right, a couple quick questions to get us into today's lesson. First one, what is the opposite of negative 5? Okay, remember we're talking about opposites. We're talking about opposite signs. So that's going to be positive 5. And similarly, on the same token over here, what is the opposite of 7? Again, opposite sign would be negative 7. All right, let's flip on over and aim for today. Our aim for today, Kipsters will be able to describe the opposite of a sum. And use breaking mixed numbers down. All right. So we start with this idea of understanding the opposite of a sum is the sum of its opposites. So here I have it written down, kind of what we're looking at today. The opposite of a sum is the sum of its opposites. Okay, so what does that really mean? Let's look at an example where we've chosen two rational numbers. For instance, let's say we have 7 and negative 2. So the sum of 7 and negative 2 is going to be positive 5. The opposite of that sum is going to be negative 5. And I'm not really sure why I ended up with these extra 2 rows on here. We don't need those. So we would expect the opposite of the sum. Okay, so opposite of a sum, that'd be this part here, is going to be equal to the sum of its opposites. So here I'm going to find the opposites of these values. So the opposite of 7 is negative 7. The opposite of negative 2 is equal to 2. So I should expect that this will be equal to this value, the sum of its opposites. So negative 7 plus 2 is indeed negative 5. So if we wrote this down, we would write this down as we're saying the opposite of 7 plus negative 2 is equal to the sum of its opposites. So the sum of negative 7 plus positive 2. Okay? So that's just a quick way to describe how to think about the opposite of a sum. It's the same thing as the sum of its opposites. All right. Looking down here at this expression, please go ahead and on your own find the value of this expression. All right, so if you haven't already finished this, pause this and let's talk about it. But we're going to think about all of the steps that go into this and kind of identifying what we do to solve this. And a couple of different methods we might go about being able to solve this. So think about what you did. Based on what I've taught most of you probably jump pretty quickly to changing these to improper fractions. So that would give me negative 12 over 5 plus 13 over 4 minus, this one's already 3 over 5. So our common denominator would be 20. So that would be times 4 over 4 would give me negative 48 over 20 plus multiplying by 5 here would give me 65 over 20 minus 12 over 20. And kind of our justification here is this is just improper fractions. Change to improper. Change to common denominator. And the next step, we've talked about not really dealing with subtraction anymore, so I'm going to go ahead and change that to add the opposite. Negative 48 over 20 plus 65 over 20. Add the opposite. Change subtraction to add opposite. Kind of our justification there. And then probably starting to combine the different values. So combining these two, that's going to give me 17 over 20 positive plus negative 12 over 20. Combine those two, that's going to give me 5 over 20, which simplifies to 1/4. So this is just using the associative property, in a sense, to go ahead and add whichever values we wanted. To get down to that step. And this is kind of this is really just no property, but then in the end simplify. So this is the method that most of you probably jump to because that's the way you've been taught to do it. However, let's think through this maybe a different way to see if there's something that helps us, or we can look at this a little bit differently. So I'm going to jump over here. I'm going to rewrite down the problem for us. We have negative 2 and 2/5 plus 3 and 1/4 plus, minus 3/5. So my first step I'm going to go ahead and jump in and just rewrite this. -2/5 plus 3 1/4, and add the opposite, -3/5. So this is change to add opposites. Alright, the reason why this is important is because it sets me up to be able to use the commutative property. I see these two values already have common denominators, so I actually don't have to change them everything to have common denominators first. So I'm going to go ahead and use the commutative property. So I can get those ones with common denominators first. And that's great because I can go ahead and combine these two really without having to change them to improper fractions. I'm thinking about this on a number line. I'm at 2 2/5, and I add an additional -3/5. That's going to take me to -2 5/5 plus 3 1/4. Well, 5/5 is an additional 1, so this is really just -3 plus 3 1/4. So doing this was just using kind of the associative property. And here we're thinking about, really our justification here is 5/5 is 1. And now I can combine these two. And if I'm thinking about this on a number line, once again, I'm going to have -3, and then I'm going to come back 3 and an extra 4th to get us past 0. So we're going to end up with a positive, and then we have an extra 1/4. This is really just the addition here, so there's not much to really think about there. So looking at these two methods, kind of looking at them side by side, was it difficult to add the mixed numbers with different signs and the different denominators? If so, was it easier to create the denominators first, or is it easier to not create the denominators? Think about which of these methods you'd actually prefer. Which of these methods would be more challenging for you? This is kind of where we get into the idea that there are kind of several different ways we can use the properties of mathematics to walk through this problem. It also brings to the forefront the power of being able to change everything to addition. That way we can use the commutative property, or we can use the associative property to go ahead and add things in any order that we want. It helps us think about maybe dealing with more compatible numbers, which might make things easier. So let's go ahead and move on. Part of the idea behind being able to do this more quickly is some of us maybe struggle with how to deal with these mixed numbers. So let's go ahead and look up at what this might look like on a number line when we're looking at mixed numbers. So what equation does the number line above represent? So go ahead and write down the equation for what this number line represents if this is 0, this is 1, and this is -1. So you should identify that each is broken down into fourths. So we're counting by fourths here. We should identify that our arrow number line ends at 1 1/4. first arrow, sorry, negative 1 and 1/4. And our first arrow takes us to negative 1. So negative 1 plus negative 1/4. Here we should start to see the idea that when we break down numbers on a mixed number on a number line, this mixed number is really the same thing as the sum of the whole and the fraction. And we're going to see that again over here in the positives, 0, 1, and 1 and 1/4. We can write this one as 1 plus 1/4 is equal to 1 and 1/4. So let's practice really quickly, rewriting each of these numbers, kind of switching between this idea of a mixed number being a sum, or a sum can be written as a mixed number. So go ahead and rewrite each of these mixed numbers as the sum of two signed numbers, and then at the bottom go ahead and represent each sum as a mixed number. So this could be rewritten as the sum of negative 9 plus negative 5/8. Again, notice it's a negative 5/8 because we're going in the same direction here. So thinking back to this, they've got to be going in the same direction, because if we have a positive 5/8, that would actually have us cutting back into it, which is not what these sums are representing. Both parts are negative. So this would be negative 2 plus negative 1/2, and 8 plus positive 11/12. Again, these are in the same direction. So here we have these can be represented as a mixed number, negative 1 and 5/8, because they're going in the same direction. Looks like this one on your paper is supposed to be 30 plus 1/8, which would be 30 and 1/8. Kind of gave away that one there in the work. And finally, this one should be negative 17 and 1/9, because those again are going both in the same direction. Okay, looking over here on our partner work time, go ahead and answer each of these questions. So you're going to start by representing the situation with an expression involving signed numbers and determining the overall change. Consider while you're working on this problem, thinking about breaking apart the mixed number and using the commutative property to go ahead and solve this particular expression. You do not have to do this, but it is one method that you might consider if you think it makes it faster. So go ahead and stop the video and go ahead and solve this problem. So below I've provided two different solutions to think about the overall change in weight here. So on the left-hand side, thinking about this solution, I've broken it apart into a sum, 5 and 1/8 is the same as 5. That makes this integer addition really easy for me. It's negative 5. Then if I add an additional 1/8, I'm cutting into that, so I'm taking away 1/8, so that would leave me with negative 4 and 7/8. Alternatively, on the other side, you can see that I've changed this to an improper fraction with a denominator of 8, and I've changed this into an improper fraction, so I have negative 80 and 41. Again, we can see cutting into each other here, and that's going to give me the negative 39/8, which simplifies to negative 4 and 7/8. So we can see that we can use this idea of being able to break it apart, or we end up using the larger numbers in the improper fractions. It's really more a matter of choice. Alright, jumping over here, the last problem, I've written a number of different justifications for individual steps that you could have used to identify the different parts. So you're always thinking about how did you go from the previous step. So this is our starting point for this first one. How did you go from this solution to this? How did you go from this to this? From this to this, this to this, this to this, this to this. So think about what you would use to justify that. And I've got, again, a list of different things that might justify different steps. Okay, so let's look through each of these steps individually. So the first one, we see we've gone from up here where we have a subtraction to down here where we've changed it to adding the opposite. So our justification here is that subtracting is the same as the sum of its opposites. Looking at the next one, we're looking at what the change is here. So the change is we've changed the order. So we went ahead and moved this addition to the front. And it looks like the reasoning for that was to get our two mixed numbers that had common denominators together. The next one, it looks like we've broken apart each of these individual mixed numbers into a mixed number and a fraction. So our justification here is the mixed number is the sum of parts. Here it looks like we've used, once again, the commutative property to go ahead and rejoin these -2/7. Now I've used the associative property by saying, hey, I want to go ahead and add these two together, even though they're not the first two on the left. And that gives me -7/7, which is equal to -1. From the next step, we just summed the first two integers. -5 plus -1, which gives me the -6. Then we go ahead and sum the next two integers. -6 plus -3 gives me -9. And then finally we sum -9 plus 8. And really that helps us justify each of this. So being able to justify our steps shows a deeper understanding of how the work is done. So a couple things to ponder before you move forward is just thinking about the ideas that we've covered in the past few days. Being able to add, write subtractions is adding opposites. Being able to break apart mixed numbers into individual pieces. The whole point of this is being able to move to an answer more efficiently, to be able to answer things more quickly so we can break apart numbers and move them together so they're in more compatible terms. So maybe it's easier to add two things that already have the same sign and the same denominator. Maybe it's easier to add things that are integers plus integers and then fractions plus fractions, and then going ahead and dealing with it from there. So just one way to think about what we've been learning today, how to use the associative property, how to use the commutative property, how to use this idea of adding opposites, how to think about breaking apart these different mixed numbers. They're all just ways to think about how we can add numbers maybe more efficiently and really help us with sometimes our mental math. All right, so please go ahead and move on to your exit ticket.